Assalamualaikum, my name is Mohd Alif.
Hi, my name is Mohd Alif.
Assalamualaikum, my name is Nabil Imran.
Hello, my name is Eiman.
Hi, now I will explain about the mass transfer. Mass transfer is the net movement of component in mixture from one location to another location where the component exists in different concentration. Thermal option of the liquid and gas particle of temperature absolute zero. Net flux of molecule from a region of higher concentration to lower. Once the concentration are equal, the molecule continue to move. But
Since the molecules are still in motion but an equilibrium has been established, the end result of molecular diffusion process will eventually result in complete mixings. Okay, right now is the diffusion in gases. This is our topic in this video. Transparent of material in stagnant fluid or cross streamline of a fluid in laminar flow occurs by molecular diffusion. Random movement of all molecules occur so that after a period molecules are found remote from their original position. Using Fick's law. Fick's law equation is like this.
Hi, my name is Eiman.
And my name is Nabil.
We are to do the experiment about the diffusion in gases.
Okay, the experiment is about the usage of yeast to produce carbon dioxide. These are the apparatus materials needed. First of all, sugar, balloons, yeast, a bottle water, and water, preferably lukewarm. Now we're going to perform the experiment. First of all, take your bottle water. Firstly, put yeast in the bottle. Next, we put sugar. And then we insert the water. You can put it beforehand or afterhand. Close the cap and shake well. Okay, now we put a piece of balloon on the mouth of the water bottle. Now we will wait for a few minutes, maximum 30 minutes, to see if the yeast has reacted with sugar to produce carbon dioxide. Alright, after 5 minutes, this is the result. We will come back later in the next 15 minutes and the final 30 minutes to see the final results.
Okay, this is the balloons look like after the more CO2 absorbed into the balloons. So it is after 50 minutes. So
We will come back for the final 30 minutes. Alright. So now, this is the end of the experiment. This is how the balloon looks like after 30 minutes. Disclaimer: the following scenes may be funny but involves molecular diffusion in gases. Viewer discretion is advised. Bro.
Who's that? Who's that?
No,
That is you,
man.
No, man. Hey, it wasn't me. Hey, no, it was not me.
Okay, jokes aside, farts are also gases excreted from the human body. The gas diffuses with the ambient air, resulting stinky smell spread throughout the room. Here is a video explaining how it works. I hope you have a better understanding of molecular diffusion in gases.
In this lesson, we are going to learn about diffusion of gases. This will help you to understand how gases behave and also explain why smells spread. Before we start, you need to recall what solids, liquids and gases are like in terms of their particles. In particular, I'd like you to ask yourself, how are the particles arranged in a gas? Pause the video and restart it when you think you have the answer. The answer is the particles in a gas are spaced out and move about very quickly in random directions. Did you get it right? This, of course, explains why a gas takes the shape of its container. It's because the particles will each continue to travel in a straight line until they hit something, in this case the wall of the container. So, the smelly gases given off by rotting vegetables in a sealed box will fill the box with rotting vegetable smell, but you won't be able to smell them outside the box. However, take the lid off the box and those particles will no longer bounce off the lid and be contained. They will start to escape into the air around the box. You'll soon notice the effect and will be able to smell the rotting vegetables. And that's those gas particles reaching your nose by diffusion. Diffusion is the random movement of one gas through another, from a region of high concentration, in this case inside the box, to a region of low concentration, in this case outside the box. It is a process that doesn't rely on wind or air currents. It will happen even if you are inside a building and the air is completely still. Now, there are many examples of diffusion, but smell is probably the most obvious one. These could be food smells, body smells from other people, the scent that a plant gives off to attract pollinating insects. And the same even applies with the smoke from a candle after it has been extinguished. It spreads out, and it's all due to diffusion. Now here's a challenge for you. If someone walks into a room with some fresh flowers, why does it take a while for the smell of the flowers to fill the room? Why can't you smell them straight away? Pause the video, have a think, and restart it when you think you have the answer. Well, just as the gas particles can hit the walls of a container and rebound, the particles can also hit each other. It doesn't matter if there is only a single gas or a mixture of gases. These collisions between particles are always taking place. It's very similar to trying to walk in a straight line through a busy crowd of people or a marketplace. It's very difficult to do without bumping shoulders with someone and changing direction. This explains why it takes a while for a smell to get from one part of a room to another. The high concentration of gas or smell particles takes time to spread out due to the collisions with the other gas particles in the air. And that is diffusion.
Alright, so why we choose this topic? We choose this topic because gas is we use in our daily application life. Gas is everywhere, which is occupied space. First, we can see the example is the pumping bicycle tires. The concept is same, which is from the higher concentration in the pump to the lower concentration in the bicycle tires. Another example is the helium in the balloon. The longer time taken, the smaller the size of the balloon. This is because the helium particle is very small, tiny particle, which is it can diffuse out from the balloon perpendicular to the time. So the conclusion can be proposed by Alif.
Okay, for the conclusion, the gas occupied space according to the theory. The concentration moved from high concentration to lower concentration. According, we have concluded the experiment was success. The balloon was expanded and fart smell can reach to the surrounding. Thank you.